Who knows the degree?
7.
What is the leading coefficient?
Positive.
And behavior then, together or separate? Separate going. Remember, leading coefficient tells you where you end. How many turns could this guy take?
6. 4, 2.
The zeros, where's our first zero at? 0, and what does it do? Cross. So x in front always gives you 0, doesn't have an exponent. What, next one? -1, what does it do?
Cross.
Last one, what does it do? Sway. So anything bigger than 3, if it's even, it bounces. If it's odd, it sways. This 2 in front only affects one thing. What is the only thing that it tells us?
Would you like calculate the maximum?
It would be how wide, but like within this list. The important thing about that 2 is that it's positive. That number in front only gives us a leading coefficient. It would affect the graph, like how high it goes, how low it goes, but for the sketching purpose, that doesn't give us a 0. The number in front doesn't give us a bounce. It's just, it's a positive number. So your sketch, 0, -1, 3. So you cross, cross, sway. How many turns? 2. The only difference between a sketch and a graph, and when you guys turn in your homework, so if you turn in your half white sheet and you don't have 5 points on it, it's because you didn't actually graph it. Because a sketch is your first step in a graph. To then graph it, you just need to figure out how high that goes. So what number would you plug into a table to see how high that goes? -0.5. You plug in between, see how high it goes. To see how low this goes, what numbers could you plug in? 1 and 2. So when it says graph, it first means make a sketch, then make a table, and then put it on graph paper so you can actually count out how low and how high it goes. Today, what we're going to go through is, it seems kind of backwards. Our whole goal for the rest of this chapter is to factor things, to solve them, to find out where it touches the x-axis. Up until this point, everything has been factorable. You could use that formula, grouping, things like that. What we're going to start looking at is, what if you can't factor it? How can you find a factor? Which is weird. Like, you can't factor it, but there are factors. Because what are factors? Like, what are the factors of 10? 2 and 5. Because 2 times 5 is 10. So factors are what you get when you multiply things together, but you can also think of it as division. 2 and 5 are factors because they divide 10. Is 3 a factor of 10? No, because if you were to divide it, you would get a remainder. So that's what we're going to start looking at, is how does division help us with factoring? Because factoring is multiplication, and what undoes multiplication? Division. So today it seems like it's kind of weird, because what we're going to do is we're going to go through division, but I'm giving it to you in a very sheltered way. Like, here's an equation. Here's something, divide to see if it's a factor. Because if it's a factor, you're not going to get a remainder. What we're eventually going to get to is, I'm just going to give you an equation and say, go use division to find the factors. Today you're given the factors to do it. In order to do this, we have to remember how to long divide. So copy down 496 divided by 16. We are going back to long division, which is everyone's favorite month in middle school. When you divide those, which one is going to go inside?
496.
Yep. So it's 496 divided by 16. The reason we're going to first do this with numbers is the process of division doesn't change. Eventually, we're going to be dividing equations rather than numbers, but the process is the same. When you divide, you first check to see if this outside number goes into the first number there. So does 16 go into 4?
Yeah.
No. 16 does not go into 4. 16 is too big, right? So now what would be the next number you check? 49. Does 16 go into 49?
Yes.
Yes. How many times?
3.
3 times. Put a 3 up there. That 3 and the 16 now multiply. What's 3 times 16?
198.
And then what do we do to the 49 and the 48?
Subtract.
Subtract to give us a 1. What then happens? Everyone's favorite part of dividing? Bring down. Process repeats. Does 16 go into 16? How many times? Once. Repeat. What's 1 times 16? Subtract. What do we get? 0. Is there anything left to bring down? No. So this 0, whatever you get at the very end, is your remainder. Since you have a remainder of 0, is 16 a factor of 496? Yes. 16 is a factor. What else is a factor? 31. 16 times 31 is 496, so they're both factors of it. We're looking for factors of equations, so that's why we look to division, because you know right away if you have a remainder or not. We're going to do one more with numbers before we start doing equations. So 542 divided by 25. First check, 25 into 5. No, 25 into 54. How many times? 2. Multiply. 2 times 25? 50. Subtract. What do we get? 4. What do we do with the 2? Bring it down. Repeat the process. 25 into 42. 1 time. 1 times 25. Subtract. Do we have anything left to bring down? No. So that 17 is a remainder. So right now, you know, is 25 a factor of 542? No, you get a remainder when you divide. The ways that you guys have learned how to deal with remainders. The first way you learn how to deal with a remainder is you just said my answer is 21 with a remainder of 17. The second way you learn how to do it is you learn that you can add a decimal and a 0 so you can keep going and get a decimal answer. The way we're going to write it is actually closer to this way. We have 21 whole times it went in, and we had 17 pieces left over. So we're going to write it as a fraction. 17 of those pieces were cut up into 25 parts. So your remainder is a fractional part left over. Like when I was dividing it, I had this many pieces left over. When we divided it, we cut it up into 25 pieces. What is 17 divided by 25? 0.68?
Yep.
So this is 21, whole 21, 0.68. If you do 542 divided by 25 on your calculator, what do you get? Yeah, 21.68. So writing our remainder as a fraction gives us the same answer as if we were to continue on with the division. So we are going to write our remainders as fractions because that's what they are. When you divide, you cut things up into pieces, which is what fractions are. The remainder is how many of those pieces you have left over. Starting into expressions and equations. Okay. Copy that guy down. X squared plus 9x plus 6, and we're going to divide it by x plus 6. Division is an operation. You guys know how to add binomials, subtract binomials. You know how to multiply with FOILing. So division makes sense that you can divide because you guys have learned how to add, subtract, and multiply. If you think about it, it's kind of weird that it's taken until Algebra 2 for you to learn how to divide these. So division starts out the same way, where you have your inside part divided by your outside part. The process is the same. It's just weird because you have numbers and variables. The important part are the leading terms. So x is the leading term here, 4x squared is the leading term there. So you have to change an x into a 4x squared. So x times what gives you 4x squared? Number-wise, what does it need? A 4. Variable-wise, what does it need? It has one x, it needs 2. An x. Because if you think about it as multiplication, like what do I need? That's what division is. It's thinking about like if you divide, you get what you would need. So you always do that first, and then you multiply this. 4x times x. Since this is a expression though, the 4x also multiplies with the 6. So what's 4x times 6?
24.
So you still multiply through. What thing then happens to these two pieces? They subtract. We don't want to subtract. We want to add the opposite. So to show our subtraction, automatically just change those signs. Because adding the opposite, adding a negative, is subtraction. What's 4x squared minus 4x squared? 0. What's 9x minus 24x? Negative what? So to show the subtraction, just change the signs because then it's just easier to look at. And then you guys know the next part. What always happens at the end? Bring down the 6. Since it's an expression though, the sign also comes with it. So you bring down just like you did before, but you're bringing down the plus 6. The process repeats. Now we want to check how does x change into a negative 15x? Negative 15. Multiply it through, so negative 15 times x is negative 15x. Negative 15 times 6. 15 times 2 is 30, so it's 3 of those sets. 90. And since it's a negative 15, negative 90. We then have to subtract those, so to subtract it, what happens to these signs? They switch. So whatever the signs are when you multiply it, just switch them, because negative 15 plus 15, 0. If the first ones don't go away, you did something wrong. The second one, oh, what?
So like the sign depends on the first part, the first one.
Yeah, the sign up here?
Yeah.
Yes. Do we have anything left to bring down? No. So what is this 96? So your remainder. So you know, did x plus 6 evenly divide that polynomial? No. So is x plus 6 a factor of that polynomial? No. Which means if you were to factor this, would you ever get a parenthesis with x plus 6? No, it's not a factor. So if it's not a factor, the only thing I'm going to look for is, okay, where's the answer? In a division problem, where's the answer? At the top. So our answer is 4x minus 15. And then we're going to write our remainder as a fractional part. So it's plus 96, because it's a positive 96, over x plus 6. So when you write your remainder, it is always the number you had left over and the number that was on the outside. So you don't even need to think about it. Whatever you have left over goes on top. Whatever you divided by goes on the bottom.
Do we ever have to like reduce?
Nope.
Okay.
Don't ever worry about reducing, anything like that. So the main thing is that is not a factor. Copy that guy down. Step 1, check the beginning. How do you change a 2x into a 6x squared?
3x.
Multiply it down, so 3x times 2x, 6x squared. 3x times 1. We now have to subtract those, so what happens to your signs? They flip. So 6x squared minus 6x squared, 0. These first ones will always go away. 7x minus 3x, and then bring down your plus 2. Repeat the process, except for you check 2x with 4x. So how do you change a 2x into a 4x? 2. And it's a positive 2, so you have to put plus 2. Multiply it down. 2 times 2x is 4x. What's 2 times 1? 2. To show our subtraction, what happens to our signs? They flip. So 4x minus 4x, 2 minus 2, 0. That 0 right there is our remainder. Since you get a remainder of 0, is 2x plus 1 a factor of that polynomial? Yes. On your homework, and pretty much always, if you find a factor, I'm going to always star it, because that's what we're looking for. In the end, you're going to be given something and it's going to say, find the factor. If you find a factor, that's a good day. So, yes, it is a factor. The answer of this is still 3x plus 2. And then just to drive home the part of we're looking for factors, in your homework it says write your answer as a product of factors. That just means write it factored. So if 3x plus 2 is a factor, where is the other factor?
2x.
Yeah, 2x plus 1. If you multiply these two together, what do you think you would get? Which is exactly what we want. So if you know something, you can put it into its parentheses without ever actually factoring it. Division, if you get a remainder of 0, you automatically can put it right into its parentheses. So that's the kind of stuff we're looking for. Next one. And this one's kind of long, so if you're at the bottom of a page, I would go to the next page. Start at the beginning, x squared and 3x to the 4th. 3x squared. So it's kind of nice. The number, pretty much whatever you would multiply by, the exponent, you just subtract them. That 3x squared needs to multiply down. So what's 3x times x squared?
3x.
And now what's 3x squared times 1? 3x squared. This is where you have to be careful with division. When you have exponents, can you add an x squared with an x? No. So when you write that 3x squared, you don't want to write it right here, because then it's not going to be able to work with this x cubed. So where should you write that 3x squared? Underneath the x squared. So make sure you just line up so your exponents go together. What do we do to our signs? Switch them. 3x to the 4th go away. How many x squareds are we going to have? And then here's the other weird part. You have to bring down things. What can we bring down?
5.
Everything you don't use gets brought down. Positive 9x squared. So if you skip a spot, just make sure you bring down everything that didn't go away. Now you check again, x squared into negative 4x cubed. Negative 4x. So 1 to a negative 4 just means a negative 4. You need one more x there. Multiply it. Negative 4x cubed. And then negative 4x times 1 is negative 4x. Do we have anything to line that up with? No. So just be careful. When that happens, I usually just put it right here in the middle. Just because it's not an x squared, it's not a number, but you always want to keep it in order. Change your signs. So that still goes positive, that still goes positive. How many x cubes do you have? 0. Here, how many x's were on top?
0.
0. So what's 0x plus 4x?
4x.
4x. So it adds with the 0. What do we bring down?
9x squared and 5.
Perfect.
Wait, I'm kind of confused where you got the positive 4x.
Because it was a negative, but then remember to subtract it when we change the signs. So negative goes to positive, positive goes to negative.
Oh, okay, so it goes in 4 essentially.
Yep. So always change the signs. Each time we divide, do you guys notice what's happening to our biggest exponent? It's getting smaller. It's going down by 1 step. All right, next, x squared into 9x squared. 9x or 9?
Or 9.
So we have 9x squared plus 9. Where should I write the plus 9? Under the 5. To show the subtraction, what happens to our signs? They switch. Those are gone. 5 minus 9. What do we bring down? Now we would have to check x squared into 4x. Can you make an x squared into a 4x? No. Once your exponent down here is smaller than what's up there, you're done. Can't do any more. That's your remainder. So is x squared plus 1 a factor of that huge polynomial?
Nope.
No, it's not. So if it's not a factor, you just have to write out your answer. And where's your answer in a division problem? On the top. The quotient is on top. So it's 3x squared minus 4x plus 9. And then your remainder gets written in with this. So it's plus your fraction. The remainder is on top. And then what goes on the bottom?
2 squared plus 1.
Yep, x squared plus 1. So whatever you divided by goes on top. Whatever your remainder was goes on top. Whatever you divided by goes on the bottom. You don't even need to think about it. There you go. Biggest thing is this a factor? No. We're going to do one more. And I'm going to give you guys a head start on it. So is x minus 4 a factor of that polynomial? It's asking a yes or no question. So if you want to know something is a factor, when you divide it, what should your remainder be? 0. So we're going to go through and divide this. X into 5x squared. What does it need?
5x.
So you have 5x squared minus 20x. What happens to your signs? Go away. How many x's are you going to have? Bring down. So there's step 1. Now repeat. X into 3x. Multiply down. Signs. Remainder. So overall, is this a factor? Yes. If it is, write it as a product of two factors. So what's one of our factors? X minus 4 and 5x plus 3. Once you get good at that, that's easier than sitting there and doing the whole, like, okay, what multiplies to 12 gives me a 17 in the middle with a 5 and a 1. So it's the same outcome, putting it into its parentheses. The leg up you're getting today is that you're being told what to check. Homework needs to be done on a separate sheet of paper. You're welcome, Amanda. And remember, if you ever need paper, this bottom drawer is just filled with it. Filled to the gills.
I didn't know drawers had gills. It's interesting. Depends on what type it is. Does that mean drawers are living creatures then?
Yeah. To make sure we're good with the directions, the last 4 are asking you if it is a factor. So for 17, 18, 19, 20, you're doing this process. Dividing, see if the remainder is 0. Final answer should be yes or no. And then if it is, write it out. If it's not a factor, just write no. The middle, or part 1, when you're asked to solve the following by using long division, Put a star next to the ones that resulted in finding a 0. So if your remainder is 0, put a star, and then write it as the product. So your second ones will either look like this, or if it's not, then you just write your answer that way. So the first part is just straight up do the division. If your answer is a 0, write it out. If not, just write out the remainder part. Second part should be yes or no. Tomorrow, what we're going to do is just learn another way of dividing. Same idea of we're dividing to see if we get a remainder or not. It's just a different way to divide it rather than long division. So technically, right now, you have every skill you need for the quiz next week. Tomorrow, we're just learning another way of dividing. So the rest of this chapter is pretty much everything you've seen before, but just more practice. That's all.